Hello friends, welcome. Welcome to this presentation from Risingpearl. Friends, as you know, we have started a brand new series 2, where we are discussing triangles. This is webisode number 2, and today's topic is general discussion on comparing triangles, and we will revisit congruent triangles. So let's get started. Now let's start by doing a quick recap of what is a triangle. A lot of the things about triangle and a lot of things you will see in this webisode we have done in tremendous amount of details in our last class, and I'm going to include the video links for those down below. So what is a triangle? Triangle is a closed figure formed by three intersecting lines. So in this diagram I have got line L, line M, and line N. I have three lines that I have drawn. They are intersecting lines, and then when you draw these lines, the intersection that you find, which is highlighted in here, that forms a triangle, right? So a triangle has three sides, and we name the three corners. These are the vertices. Let's call it A, let's call this vertex B, and let's call this vertex C. So triangle has three sides. Let's write it here, three sides, right? And it has three angles. So this is what is meant by a triangle: three sides and three angles. Now, in the last video, we were looking at comparing line segments, angles, and circles. We noticed that for a line segment, the way we uniquely mention or explain a line segment is by the length of the line segment, right? So if this is a line segment AB, we basically say AB equals to some length, right? This is how we measure a line segment, some length unit. For angles, we know that we measure by how far it is a measure of this angle, that is how far this moving arm away from the base arm, right? So this is what is the measure of an angle. For a circle, we define a circle by discussing the radius. So now, as you notice, in each of these cases, whether it is a line segment or an angle or a circle, there is one measurement that really defines that particular thing. So for line segment, it is the length of the line segment. For angle, it is the measure of this angle. For circle, it is really the radius that really defines a circle. Then, what about the triangle? So this is very important to understand, because a triangle has three sides. Let's name this triangle as A, B, C. So our triangle has angle A, angle B, and angle C. Also, it has the side AB, it has the side BC, it has the side AC. So friends, it is important to understand that whenever we talk about triangles, we don't have only one measurement. We have three angles and we have three sides. So whenever we compare triangles, we have to look at each of the angles and we have to look at each of the sides. So with that said, let's move on and let's try to compare some triangles. So here, let's call this is figure A or figure 1, and this is figure B, and this is C. So I have got two triangles or a pair of triangles in each of these figures. So what do you think about these two triangles? So do they look the same? Are they equal? One is greater than the other? Well, first thing, whenever we talk about triangles, and you will notice this is true for any polygon, right? Closed shape made up of straight lines. So this is true for all polygons, that when we talk about triangles or polygons, we don't really use the term greater than, less than. We do that with numbers. So here we are trying to find out if they are equal or there is any other relationship. Clearly this is a right angle triangle and there are no right angles in here. So they are not equal triangles, right? And a very layman definition of equal, two objects equal, is that if you take one object and put it on top of the other object, if it totally covers the second object which is underneath, then we say they are equal, right? What about the two triangles here? Now, these two triangles are not equal. Clearly, if I take the small triangle, put it on top of it, this is not exactly going to cover this. So not equal. But there is some similarity between these triangles, and we will revisit them later on. Let's talk about the C, the two triangles in C. Here, if I take this triangle and put it on top of this, it will exactly cover the triangle. And we say these two triangles are actually equal. So when we say the two triangles are equal, what we mean is they are actually congruent. So whenever we talk about geometrical shapes and we use the term equal, let us just write it. Equal means congruent, right? Whether it is equal or identical, they mean they are congruent. So we say these two triangles are congruent. And then what do we mean by congruent triangles, friends? We have seen that again in our last class. So if I have two triangles, right, and let us just name them triangle A, B, C, and triangle, let's call it PQR. If I have two triangles, ABC and PQR, then if these two triangles are congruent, what does it mean? It means that the corresponding parts must be equal. So mathematically speaking, well, in a layman's term, you can explain you put one object on the other and they should exactly cover. But mathematically speaking, when we say two triangles are congruent and we represent that by, you have seen this again in your last class, by this side between the two triangles. So when two triangles are congruent, if two triangles are congruent, it means the corresponding parts are equal. Or conversely, we can say in any two triangles, if corresponding parts are equal, that means they are congruent. So let us just quickly elaborate what it means. What corresponding parts being equal means is that each of this angle, angle A, must be equal to angle P. Angle B must be equal to angle Q. And angle R should be equal to angle C. Not only that, but the measure of the side AB. So let's write it down. Angle A should be equal to angle P. Angle B should be equal to angle Q. Angle C should be equal to angle R. And you will notice that I have just put like one extra angle sign here just to make sure that 1 is equal to 1, and where you have two bars that is equal to this, and where you have three of them is equal to this. Not only that, but remember a triangle has angles and sides. So the side which is opposite to angle A, what is the corresponding side to this? It is side BC. So BC should be equal to what? A is equal to P, so the side opposite to this is QR. So BC should be equal to QR. Similarly, opposite to C is AB. AB should be equal to PQ. PQ. And what is left is AC. AC should be equal to PR. So friends, very simply, if we say two triangles are equal or congruent, it really means all of this must absolutely be true. That is, all corresponding angles should be equal, and all of these sides, corresponding sides, should be equal as well. If that is the case, then we say that those two triangles are congruent. And friends, this is applicable for all polynomials as well. Now also, we have seen in great details in the last class about the theorems or the congruency rules that, let us just note them down here, which is that, let's just call this triangle is ABC, ABC, PQR. We saw in the last class in great amount of detail that if you are given any two triangles and if you see SSS or SAS or ASA or AAS or RHS, and here S means side, here A is angle, right? Side, 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 angle, angle, side, angle, 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 side, right angle, hypotenuse, side. If in two triangles, if any of these rules are valid, then those two triangles are going to be always congruent. We have seen them, we have gone through every single proof and applications of these congruency rules, theorems in our last class, and I'm going to provide those video links down below. So that brings us to the question that, remember the shape or the figure number B where we had these two triangles. So what do we call these two triangles? Are they congruent? They are not congruent. So what are they? We will look at it in the next video.